is Math 60, Intermediate Algebra, and this is 2.6, Graph of Functions. Yay! So this is following up from 2.5, which was an introduction to functions. And so here we're going to look at more graphs. For this, I'm not expecting you to know anything in particular about graphing other than being able to use a table of values. So that's how we're going to do our graphs. Now, once you get more experience with algebra, and as you move on, you'll be able to say, look at this, which is our first function, which I'm going to say is a function, but we'll double check that. F of x equals the absolute value of x. Off the top of my head, I automatically know what the shape is. So once you get comfortable with these, you'll kind of learn a whole library of shapes. So for example, I know that this makes a particular shape. You might not know this. You don't have to be able to do it, which is why I encourage you to have the calculator nearby. If you hit any numbers you don't know how to calculate, and you just be willing to write out a whack ton of values so you can graph them. So I've got here, I've printed out a nice little grid, which if you printed the notes, you got this grid as well. You can obviously do graphing just on graph paper. So, or they call it grid paper or something. It's quadrule paper. This is one that I like a lot. I like these because it's got the reinforcement so it doesn't rip out of a binder. But you can use whatever you like. I really encourage you to use graph paper of some sort. Use a grid because that's going to allow you to make a much more precise graph. The other thing I want you to remember, and I always forget, but whether it's desmos.org or desmos.com, but what I'm going to write up here, Desmos. This is a free graphing app. And if I weren't recording this on my phone, I'd be able to show you the graphing app right in front of you, but my phone is up here. Where is it? Up there, you know, making this video. So I can't show it to you, but it is a graphing app. It's also a, you can just Google, look up Desmos, and you will get to the browser version. So you can use Desmos to graph in a browser or as an app. It's totally free. There's a lot of really cool things you can do with it. You could take multiple graphs, put them all together, compare things. So it's a great resource, and I recommend that you go and look at this. So when you're graphing, you know, do the graph on your own. You know, be precise, do as well as you think you can, and then go check it on Desmos. You know, see what you got right, see what you might need to do slightly differently in the future. So with that in mind, I'm going to go ahead and get started. So I'll remind you that, oh, I just copied it down because why not? So that means y is the absolute value of x. So I'm going to set up a table of values. Tables of values are just one way to organize your work. You can use a list of ordered pairs. You can use another, like a table of values was not what I used originally. When I learned math, I had a slightly different way to do it. Everyone's got a different technique, but you want to be able to organize your work in a way so that someone reading it would understand what's going on. Table of values allows me to say, okay, let me try different values of x. So I usually start off with 0 because I think 0 is one of the more interesting cases. Y is going to be the absolute value of 0, which is 0. Okay. Then I could say, okay, when x is 1, y is the absolute value of 1, which is 1. When x is 2, y is the absolute value of 2, which is 2. And you can see this is going to keep going. 5, absolute value of 5 is 5. You can try different numbers. You're allowed to jump around a little bit if you'd like. The goal would be you need to try at least 0, some positive numbers, and then you should also try some negative numbers. Because if I just tried that, let's go ahead and just graph what I've got so far. So I've got this is the ordered pair 0, 0. Oops, did I leave enough room to do that? This is the ordered pair 1, 1. Here's 2, 2, right? Because my ordered pairs are x comma y. 5, 5. So let's look. 0, 0. Can you see this? 0, 0 is right there. Let's see. It's little tiny. 1, 1 is right there. 2, 2 is right there. 5, 5 is right there. If I look at this, and I am still regretting that my ruler really isn't speaking to me. I'm not sure where my ruler went. So I'm going to have to use a card to draw. But it looks to me like these all lie on a line. And so what I'd like to do is just draw a line, just straight through, like bam. That would be a bad idea. Let me show you why. Something interesting and unexpected happens. Let's take a look before we get too excited that we've discovered a line. Let's look at some negative values of x. So -1, y is the absolute value of -1. What is the absolute value of -1? The absolute value of -1 is +1. So now something interesting happens. When I go over to -1 in the x direction, I still go up +1 in the y direction. Okay, what about -2? Absolute value of -2 is +2. So I get -2, +2. That's there. -5, absolute value of -5 is 5. -5, comma 5. Look at that. Now, the nice thing about this is I happen to know that the graph is a V. Now, how would you know the graph was a V? Well, you might not. So you got a couple of options. One is do lots and lots and lots of values in your table of value. Try some fractions, perhaps. They're going to be hard to graph here, but absolute value of 1/2 is 1/2. What about -1/2? Well, absolute value of -1/2 is also 1/2. And that'll be hard to graph, but it'll be right there and right there. So graph lots and lots of points until you really see a shape come together. So in fact, this graph looks like a V. And in a perfect world, you're using a ruler rather than just a straight edge, and that will help you with, measurement and other sorts. But this will do a pretty good job from what we're doing. Now, I believe in arrows, and I believe so much in arrows. I put arrows on my axes, identify my axes, X and Y. I know it's very cool to leave the arrows off, but I think the arrows are really important because what they mean is this keeps going. So this is the graph of f of x. If you want to be cool, you just say f of x. If you want to be, more explicit, slightly less cool, but you're giving more information, f of x equals the absolute value of x. That's the graph. So now it says, let's determine the domain. And I don't want to just look at the domain. I want to look at the range too. So remember that the domain asks what values of x are going to be included in this graph. Another question might be, what numbers can you take the absolute value of? Is there like a maximum or a minimum value? Are there any values that makes absolute value not work? And the answer is no. The only weird one is 0 because it doesn't really have a sign. But all the others, if it's positive, it's unchanged. If it's negative, you just switch it over to the positive version. All values of x are going to be included. So my domain here, the domain of f, is all real numbers. Now, if you're asked for an interval for that, that would be from -infinity to infinity. And that's fine. The domain of functions is oftentimes all real numbers. But I think it might be interesting to look at the range. Remember, the range is going up and down what y values are involved. So, do you see points that correspond to all the positive y's and all the negative y's? And the answer is no. It starts to, right? Here are all the positive ones, but then right here, it bounces back. So instead of going straight down, It goes ba-tang, like that, like it was Wonder Woman's magical bracelet, right? Like that. Patoo, patoo. So in fact, I see a point here when y equals 0, and I see a bunch of positive y values, but I don't see any negative y values. So my range here is going to be y has to be greater than or equal to 0. It can equal 0. It's equal to 0 right there. Or from 0 to infinity. What do you guys think? Woohoo. Domain and range. 1 down, 2 to go. We can do this. Okay. Another graph. Now, this is a graph I hope that you're slightly more familiar with. I hope that sometime in the past, it may have been a while ago, you graphed an x squared or something similar. So if I've got g of x equals x squared, in other words, y equals x squared, let me start thinking about what's going to happen in that function. Oh, you know what I didn't do before I do that? I'm so sorry. Is this a function? I just asserted it was a function, but we didn't check. So remember vertical line test? We take a vertical line or a hashi or a chopstick or a puppet stick, and we slide it along the graph, and we see at any point does it passes through one point right there. Is there another point on the graph? And the answer is no. There's no other. Each time it's just for each x value, there's one y value. Okay, it's a function. Yay! I mean, I kind of said they were functions, but we should double check. Okay, back to this one that I was so excited about. This one has a name. This is going to be a parabola. And I'm hoping that somewhere in the past you have experienced a parabola, but if not, that's okay. Let's go ahead and pull together a table of values. Again, this section of the book is not focused on perfect graphing. It's focused more on how do we use graphs to get more information, like domain and range. So I'm going to go ahead. I always start with x equals 0 if I can, as long as it's part of the domain. Y is x squared, right? That's our function. So I'm going to get 0 squared, and that's going to be 0. So I've got the 0.00. Okay, 1 squared is 1. So that's, oops, already with the mistakes, huh? And my hand is totally unrepentant. It's like, yeah, I just want to go do something else. What else would there be but to record a video and teach math? Let's be honest. Okay, now so far, and here's why you want to use lots and lots of points. Because so far, if I've got the 0.00 and 1, that looks like it could be a straight line, right here. That looks like it could totally be a straight line. It could be like the one we just did, that giant V. It could be a lot of things. So let's keep going. See if it gets interesting. 2, that's going to be 2 squared, which is 4. Okay, now that's where it gets interesting. I go over to 2 in the x direction, but I go all the way up to 4. Now, let's take a look at this. Is this still a line? And the answer is no. Obviously, this is curving up. So I'm expecting it's going to go up like that. Let's see if I'm correct. 3 squared, that's 9. 1, 2, 3, and then I have to go up to 9. Yep. See how it's curving up? And then I think I can do another one. I can do 4 squared, that's 16. 4, 16. That's going to be right there. Now, unfortunately, I can only go so far. 25 is past 20, so I can't graph that one on this grid. Okay. So what happens when x is 1/2? That is an interesting number to look at. Let's look at 1/2, the quantity squared. That's 1/2 times 1/2, which is 1/4. Okay, I wish we were in person, because we were in person, I'd be doing this on a tablet, and then I'd be able to slide it open. We could look at the bigger picture, but you're going to have to take my word for this. For this point, if this is 1, and this is also 1, and this is the x, and this is the y, when x is 1/2 and y is 1/4, you go all the way out to 1/2, but you only go up to 1/4. So if I've got a point here at 0, 0, and I've got a point here at 1, 1, see how this kind of scoops? It doesn't go straight, doesn't go straight across. It goes like that. It makes like a bowl shape. So that's an important aspect. It's hard to see on this, but it's like a little point kind of goes right there if you can see it. So it scoops out and makes like a little bowl or like a cup. So next question, what's going to happen over here? I should look at some negative numbers. If it's just like the absolute value, then it'll go back up like that. But if it's like a straight line, maybe it goes scooping down and then it heads down this way. So we got to check. Let's look at -1. Remember, when you're squaring a number, parentheses, -1, the quantity squared is -1 times -1 is +1. There we go. We got that -1, +1. So we've got that point right there. And from there, I think you could guess that it's going to go like this, but double check with a couple more points. -2 does become 4, so -2 maps to 4, -2, 4, -3, -3 squared is 9. And let's see, -2, 4, -3, 9, -4, 16. And you can see that we've got that same shape on the other side. So here's the thing. A lot of people have trouble pushing when they graph. So what I'm going to recommend is you come swooping down, because pulling down is frequently easier than pushing up. Parabolas are not easy. I technically graph things for a living, and you can see I have a little bit of trouble making it beautiful, but that's pretty good. Humans are not perfect. If you want something that's perfect, go to an online graphing app of some sort. I'm going to mark my X and Y axis, make it all fancy, write that this is g of x, which is x squared. There's my parabola. And now I'm going to ask you, okay, what's the domain? The domain of G, and I know it goes up, but does it go out to cover all the x's? So in other words, is there a number you can't square? And the answer is no. I mean, there are numbers that are very large, and I would have to use a calculator or a computer to square it, but you can square them. It just takes a long time. So I claim that it's all real numbers. So that's from -infinity to infinity. Now, more interestingly, what's the range? What kind of y values do you see? I see a lot of positive y values, right, up here. Are there any negative y values? No. Why not? Well, because I'm squaring. And when I square, I take my two minuses and they become a plus together. So I'm not going to get a result that's negative. And so my range is going to be just like the first problem. It's going to be all the numbers greater than or equal to 0, or from 0 to positive infinity. It's really hard not to say to positive infinity and beyond. To infinity and beyond, but starting at 0. Okay, that was the unwritten 5th Toy Story. It was all about graphing. That's why it didn't make it big in the theaters. Although I should say, who would have guessed, right? Who wouldn't want to go watch 2 hours of animated math, right, guys? Oh, yeah. Yeah, they're totally down for that. Okay, one more. Let's try x cubed. So let me remind you that for these, you're going to go into it, you're going to look at it, and you're going to say, okay, I'm going to set up a table of values, and this is going to be a cube party. So x is 0. I personally always start with 0. If you want to start with -3, start with -3. If you want to start with 100, do 100. It's just hard to graph. Okay, 0. 0 cubed is 0. 1. 1 cubed is 1. 2. 2 cubed is, ooh, that one's hard. 2 times 2 times 2. Now, if you're having trouble with that, oops, get out of the light, Carol-Ann. Okay, oops, trying. Ring lights are so awesome until they're not. There we go. Okay, on my calculator, I've got a very simple exponent key. It's this little, it looks like a rooftop thing. It's like this top arrow, this up arrow, and that's how I do it. So if I want 2 cubed, I can do 2 exponent key 3, and it gives me 8. You could go old school and just do 2 times 2 times 2, get 8. Some people have a slightly different this key on a calculator might be x to the y or x to the box. And if you're not sure, you can always ask me or tutor, send us a picture of what your calculator looks like and we can show you where your exponent key is. Okay, so 2 cubed is 8. If you are going to go on in math, if you're looking to go, you have to take calculus, you have to go further. If that's the case, I recommend you learn your cubes, just like you learn your squares. So 2 cubed is 8. 3, does anyone know what 3 cubed is? 3 times 3 times 3 is? You got it, 27. Way too big for this graph. 4 cubed is 64. 5 cubed, 125. You got it. Okay, so I can't graph all of these, but I can graph a few. So I can graph 0, 0, I can graph 1, 1, and I can graph 2, 8. Now, if we compare this with the squared went 0, 0, 1, 1, and then 2, 4. This one is a lot taller. It's 2, 8 now. So this is going to be a much stretched up, skinnier graph in comparison, or taller if you prefer. Okay. -1. Now here's where things get interesting. -1 cubed is -1 times -1 times -1. If there are 3 minuses, it's an odd number of minuses, so the whole thing is negative. So that's where this one changes. I go to 1, -1, and suddenly this is going down on the other side. -2, -2 cubed, same thing, -2 times -2 times -2 is -8. So we're going to go down. Isn't that interesting? And now you're going to ask me, well, what do I do with this? It looks like it's a straight line and then it goes, and the answer is no. The answer is what happens if we had a close-up, if this were -1 and this is 1 and this is 1 and this is -1. This is just a sketch. If I have 1/2 cubed is 1/8. It's very small. So when x is 1/2 right there, y is going to be tiny. It's going to be like 1/8. So there's the point. There's the point. So it's on this side, it's going to scoop up like that. But then for -1/2, -1/2 cubed, that's -1/8. So let's look over here. I've got the point -1, -1. And then when x is -1/2, y is going to be like -1/8. So it kind of goes like this. This is very cool because it goes from concave down to concave up. This is a change in concavity, which is really exciting if you're a maths major. This is like, whoa, that's so cool. And for everyone else is like backing away slowly going, you guys have fun with that. But we totally have fun with that. A change in concavity is going to come up all the time in math. So, relish this moment. So what does this mean about the graph? Well, it means you can't just draw a straight line. You need to scoop up. So starting at 0, you scoop up on the right and you scoop down on the left. Can you kind of see that? So it doesn't go straight through. It's got this shape to it right in there. Okay, I've got my x-axis, my y-axis, my arrows. I'm going to write this is h of x equals x cubed, so it looks all fancy. And now let's talk domain. Same thing. Is there anything you can't cube? Well, there might be something you personally can't cube, but calculators can cube it. Sorry, not Cupid. Although it's possible. I mean, love might be in the air. La da 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 da. They're both sea creatures. They both like eating people. It could happen. Or it's possible that we could say, you know what? It's possible for two creatures of the ocean to relate in a completely platonic, asexual way. It could be they're both ace and they're just like, hey, let's go out and, watch a movie together or something. Okay, so back to this. So I've got my graph. Let's look at my domain and my range. So the domain of H, I'm going to claim for the same reasons as the last one, it's the set of reals. That you can cube any number. It might take a long time, but it's not going to fundamentally break. Cubing, squaring doesn't break. It's lovely. Now, let's look at the range. Now, in the previous two, the range has only been positives. Is that the case here? And the answer is no. If we look here, I see this arrow heading up, so it's going to be all the positive numbers, but then this scoops down and heads down, so this is going to be all the negative numbers. So I'm going to claim that the range is also the set of real numbers, so negative infinity to infinity. What do you guys think? Kind of woohoo? Kind of awesome. It's graphing. It's super fun. If you get stuck, again, Google or download the Desmos app. You can check anything there. Fun fact, if you write graph and then an equation, usually Google will graph it for you as well. So if you just want to just straight up use Google, the difference between Desmos and Google is Google will just give you a graph and be done with it. Desmos lets you, turn the graph around and change things and work with it. So it's a much more useful thing. But if you're just looking for a quick and dirty, you can do it on Google as well to check. And you can always talk to your teacher, woohoo, or the tutors. So that's it for graphing. That's it for chapter 2. Yay, we're done. We survived. Dun, 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 dun. Okay, so have a great whatever it is there. Here it's an evening, and it's a little bit late, so I'm going to say good night. Or if it's good morning, enjoy your coffee. And I will see you guys in the next video. Woohoo, math on.